Okay, thank you. Okay, so okay, first thing I want to do is make sure that everyone have my contact information, because that's how you will be able to reach me to get some extra help. Okay, so would be my contact information. So make sure you copy this down or do this print screen on your computer, so that way you have this contact information. Like I said, the best to reach me is through text message and to schedule an appointment to get together with me. My office hour is between 1 p.m. to 9 p.m. Now, if you prefer some other time schedule, you have to text me, so that way I can tell you whether I'm available or not to work with you on Zoom. And this will be my Zoom contact number, and the password would be ETT. And anything else, if you want to send some extra information to my email, so I can so you can get to me, I can get to you later, because usually I check my email either in the morning or late at night, just before I close down everything, just to check, make sure, and then respond. So anything that is not totally important, or you don't need me to respond to you right away, you can email to me. But everything else you want to do is to reach me, it's best to text me. Okay, so that way I can respond to you quicker. Okay, so that's my contact information. Make sure you do a print screen of this, so that way you know where to contact me. Okay. Okay, so the second thing we want to do is go over the quizzes from last week. Okay, so this was quiz number 1. Oh, before I go into here, so like I said, I just want to mention one more time, if you are not registered for this course, make sure you register, because the registration will be closing pretty soon. Okay, either by the end of this week, or probably it should be the end of by next week, they will be closing the registration. So you have to contact me or contact Mr. Pham, and so we can help you register for class. Okay, so make sure you reach out to us. And like I said, for to contact Mr. Pham, so you want to do is go to the homepage. Now this is where Mr. Pham's name is right here. He's the head instructor, and his email would be right here that you can contact, and you can reach him pretty quickly through his cell phone. Okay, so that's the best to reach him. Call him, and so he can help you. Okay, so that's from the website. Okay, now back to quiz number 1. Okay, now quiz number 1, they said to add 250 times 10 to the negative 6 plus 1 times 10 to the negative 3. Okay, no, 10 to the negative 6 mean 10 to the power of negative 6. Okay, so we're going to be adding these two together. So in order to add them together, we have to get the 10 to the 6 and 10 to the 3 to match. Okay, so 10 to the 6 and 10 to the 3 to match. So therefore, in order to get 10 to, so we want to get down to 10 to 3, because all the answer is in 10 to 3, either positive or negative. Okay, so if we put 10 to 3 here, so we move the decimal place to 3 place to the front. So this will be go to negative 3. Okay, now we can combine the whole number together, this and the 1 to get to. So that's why I regroup these, or just factor 10 to the 3 out, so leaving you 0.25 plus 1 times the quantity 10 to negative 3. So you got 1 plus this, which is 1.25 times 10 to the 3 to negative 3. So the answer would be A as an apple for number 1. Okay. So number 2, subtract 400 times 10 to the positive 3 from 2 times 10 to the positive 6. Okay, so in order to do subtraction, we have to make sure the power 10 have to match to each other. So therefore, since the answer is 10 to the 3, so everything had to be to 10 to the 3. So this one down to 10 to the 3, so we multiply this by 1,000. So now that's 2,000 minus 400 times 10 to the 3. Now we just factor out 10 to the 3 out. So leave you 2,000 minus 400. So that's 1,600 times to 10 to the positive 3. So the answer is C as in cat for number 2. Okay, number 3, divide the 500 times 10 to the 5 by 25 times 10 to the 2. Okay, so in this case, we're going to be able to group them together. So we're going to be grouping these whole number, the 500 and the 25 together. So that's 500 divided by 25, and then the 10 to the 5 would be same 10 to the 5, and so it's divided, it's going to be minus the 2 here. So 500 divided by 25, that will be 20. And so 10 to the quantity 5 minus 2, so that's 10 to the 3. So 20 times 10 to the 3. So the answer is B as in Bob for number 3. So any question number 1, 2, or 3? Okay, no question? Okay. All right, so question number 4. Okay, convert 22 milliamps to microamps. Okay, so 22 milliamps, so converted to microamp will be 22 times 10 to the 3 positive 3 microamps. So therefore that will be one answer. So this is correct. And then we got 22,000 microamps. So 22 microamps, that's also correct. So the answer for that would accept A and C would be, the answer is D. Okay, D as in David would be the answer for number 4. Okay. Number 5, convert 1.5 kilo ohm to ohm. Okay, so 1.5 kilo ohm is the same thing as 1500 ohms, or 1.5 times 10 to the positive 3 ohm. Okay, so you got this one here would be the same thing as B, and the other one would be 1500 ohms. So there's no other one. So the answer is only B. B as in Bob for number 5. Okay. Number 6, convert 1500 hertz to kilohertz. Okay. So 1500 hertz is the same thing as 1.5 kilohertz, or you go 1500 times 10 to the negative 3 kilohertz. So this one here would be this one right here. So the answer is only C as in cat for number 6. Okay. So any question on number 4, 5, or 6? All right, so next one. Okay. So number 7, okay, resistance and current. Okay. So resistance and current are they are inversely proportional. Why is it inversely proportional? Because if resistance decrease here, the current would increase. The increase would go up. So resistance go down, the current will go up. So that's why it's opposite. So it operates inversely proportional. If you're talking voltage and current, then the both would be, if the voltage go up, then the current has to go up. So that would represent directly proportional. Okay, so voltage and current would be this one here, or voltage and resistance would be something like this one, which is the directly proportional. But if you look at current and resistance, then it would be inversely proportional. Okay, so the answer is C as in cat for number 7. Number 8, if the resistance in a circuit is double, the voltage remains the same. The current is, okay. So we keep so the formula is I equals V over R. So if R is equals 2, then that means I equals V divided by 2. Therefore, the current is been turned by half. Okay, so the answer is A as an apple for number 8. Okay. Number 9, a sine wave with 20 volt peak to peak has RMS value of, okay, so we got 20 volt peak to peak. Okay, the formula, according to the formula, is that VRMS, it only takes V peak times 0.707. So therefore, if we take the 20 divided by 2, that will give us just the peak value. And then we multiply by 0.707. That will be giving us 7.07 VRMS. Okay, so the answer is B as in Bob for number 9. Okay, any question number 7, 8, or 9? Okay. All right, so next one. Okay, number 10. Okay, so most of you already work, some of you already completed some of the DC fundamental in the lab vault in the classroom. It's something to read the color code on the resistor, similar to this one right here. Okay, so this determine the resistance of resistor having the color codes shown. Okay, so the first one is brown. We know that brown is 1 because that brown is 1. Green, the second band is 5. Okay, so green is 5. Okay, yellow, it will be the 4, and the silver is going to be silver is plus minus 10%. Okay, so we're going to be, so this is 1, 5, so 1, 5, and this will be, you represent the multiplier or the number of zeros. Okay, so that would be 10, so 15 times 10 raised to the 4th, okay, ohms plus or minus 10%. Okay, so now we convert it, so to if we multiply by 10, so if we move 1 0 here, reduce this by 1. So therefore 10 to 3. 10 to the 3 is the same thing as a kilo. Okay, so that's why 150 kilo ohm plus or minus 10%. So the answer is B as in Bob for number 10. Okay. Number 11, determine the total resistance for A to B. Okay, so from A to B, so this is represent a parallel circuit. So therefore you can use, since you only have 2 resistors, you can use product over sum formula. Product over sum formula said R1 times R2 divided by the quantity R1 plus R2. Okay, so therefore it'd be 500 times 200 ohms divided by the quantity 50 ohm plus 200 ohms. So 50 times 200, that would be 10,000 ohms. And the 50 plus 200, that's 250. So 10,000 divided by 250, that would yield 40 ohms. So the answer is C as in cat for number 11. So any question number 10 or 11? Okay, no question. Next step. Okay, so this one determine the total resistance from A to B. Okay, so from A to B, now you can also apply the formula. So R equivalent is R1 is parallel with R2, parallel with R3. So R1, R2, R3, they are in parallel. So you apply the formula 1 over the quantity 1 over R1 plus 1 over R2 plus 1 over R3 close that. Okay, and then you put that in and then you calculate, and that comes out to about 16.7 ohms. Now the other shortcut, now if you know if all of them is in parallel, and you have to do is take one, you have to do it just take one resistant value and divide it by the number of branches in the parallel. So this one is 50 ohms divided by number of branches. So 1, 2, 3. So they're 50 divided by 3. So same thing as right here. 50 divided by 3 comes out 16.7 ohms. So that way, if you look at something that is the same value on all the branches, just take that, just take one resistant value and divide it by number of branches. That will give you the answer right away, rather than go through the long process of doing this calculation. Okay, so that's your shortest way, and that will help you in your shortcut. Okay. And so the answer is C as in cat for number 12. 13 for the circuit shown, solve for the total resistance. So this one is in series circuit, so be the series that just add the resistance together. So 20 plus 40, so that's 60 plus the 30, so that's 90 ohms. Okay, so the answer is A as an apple for 13. Okay, 14 for the circuit shown, solve for the total current. Okay, so current equals E divided by R total. Now R total, we solve it here in 50 ohms. E is 120 volt. Okay, so 120 volt divided by 90 ohms, that yield 1.33 amps. So the answer is B as in Bob for number 14. Okay, any question number 12, 13, or 14? Okay. Okay. No question. All right, next set. Okay, number 15 for the circuit shown, calculate voltage R1, VR1. So VR1, and we know the current from the previous step. Now you can use the current or you can use the voltage divider formula, okay? So in order for voltage divider, say E equals to E times R1 times the divided by the total resistance, okay? So total resistance be R1, R2, R3. Okay, so therefore it's going to be, so E would be 120 times 20, that would be, that's 240 divided by total resistance, 90 ohms. So that yields 26.6 volt. So the answer is C as in cat for number 15. Okay, number 16 for the circuit showing, calculate voltage across R2. Okay, so we same thing. Now we take the E times R2, so this one times this one, which would be 4,800 volt ohms, and divided by 90 total resistance, which is 90 ohms. So the answer comes to 53.3 volt. So the answer is B as in Bob for number 16. Okay, for 17, for the circuit showing, calculate voltage across R3. So R3 is here. So this, so 120 times R3, which is 3,600 divided by total resistance, 90 ohms. So the answer comes to 40 volt. So 40 volt, so round it up or round, so this one has been, this one used the current to do this calculation. That's why it's come 39.9, which is close to 40 volt. That's good enough. Okay, so the answer is A as in apple for number 17. Okay, any question number 15, 16, or 17? Okay, no question. Okay, page down. Okay, for the circuit shown, calculate the power dissipated by R3. Okay, so R3 would be here. So we got R3, which would be 40 ohms. Now we got this, so VR3 that was done earlier. So VR3, which is here, which is say 40 volt. So that's why we got VR3, 40 volt, R3 is 30 ohms, okay? So therefore we're going to use the voltage and resistance formula. So power, we have this power, or same thing as this, or this one. So we're going to use this voltage squared divided by R, okay? So it'll be VR3 squared divided by R3. So that's be 40 volt squared divided by 30 ohms. Okay, so that's so for 40 square, that will be 1600 volts square divided by 30 ohms. So that comes to 53.3 watt or 53.4 watt. That's close enough. So the answer is C as in cat for number 18. Okay, so any question number 18? Okay, so no question on that. Okay. So go ahead and close that. So anybody have any general question or anything about this quiz? So make sure you go through, and if you didn't do this quiz, make sure you go through and restudy this, because these same material will be showing up on your final exam. And so make sure you understand this, because the number might be different, but the process will be the same way to measure, to calculate that and come up with the answer. Okay. So, okay, so any general question or anything? Okay, so that's pretty much it. Okay, back to you, Mr. Pham. Thank you.
Thank you, Sam.
You're welcome.
Let's see. Okay. So today we go back to the RC. Only thing this is the basic thing we already get through to you, okay? And make sure when you're looking into the sine wave, you're able to identify what we need to know. Second thing, we're talking about capacitor. Okay, so that is the symbol for the capacitor. When you're working on the lab, you can see the capacitor. And the capacitor, they will be either non-polarity or polarity. Okay, and the unit for the capacitor will be farad, and you can get a millifarad, microfarad, nanofarad, or pico. Okay, and also they are telling you how the capacitor will be charging. Okay, in general, if you're looking back, you can see this is the charging on the capacitor. At the beginning, VC equals 0. When you connect the power, they will be charging, but they cannot go direct quickly to the power voltage, but they have to take a time. You see that? When they go up to this point, then now they be full charge. Then they no more charging anymore. So that's what they call it, transient. And this will be a steady. That means they be full charge. So basically, when they full charge, VC equal the power supply. Current will be equal 0. So that's why current equal 0 look like the capacitor will be open. Okay? To see the time constant, tau equal RC, that means the time for the capacitor charging up to 63.2% of the maximum value. In this tau equal RC, R is farad, C will be in the farad, R have to be in ohm. Okay? If it's not, you have to make a change. And what they said, after 5 time constant, the capacitor will be full charge. Okay? This one they already telling you. Another one, they will be discharging. This is the charging. And when they start here, they connect the switch into the ground. Capacitor now will be the power supply, and the current will be flow dissipating into the R. So they start discharging. Okay? Until they will be 0 volt. Okay? This one I already correct for you guys. The formula. That's a typo problem. This is the formula. Okay? And also the answer. This is the answer yesterday we get it. Now, when we're talking about capacitor in series or in parallel, if you can see a capacitor in series, so they will be opposite to the resistance. You want to calculate the total capacitance. Then they're using 1 over C1 plus 1 over C2 plus 1 over C3 and so forth, okay? So if you get only 2 capacitors in a series, you can use the same formula like resistor. C1 times C2 divide C1 plus C2. And now we're talking about capacitor in parallel. Then now they opposite to the resistor. So C total in the parallel, you add them up. Okay? And that's what we already did it. Okay? Now we're talking about, this is the important thing for you. when a capacitor, when the AC signal, that normally they're talking about sinusoidal, applied to the capacitor circuit. The capacitor creates a resistance. That's called a capacity reactant IC. Represent opposition, that capacitance present to current for sinusoidal and calculate in the following formula. So basically, when you connect the capacitor into the AC circuitry, now capacitor will be get the resistance. But they not call a resistance. They call capacity reactant. IC equal 1 over 2 pi FC. In this formula, you know Joule, you know pi. F will be in Hertz, and C have to be in Farad, and IC have to be in Ohm. Okay? The relation between capacitor voltage and the capacitor current. The current will be lead the voltage 90 degrees. Now you can see this will be a display on the oscilloscope. So this, the red one here stands for VC, 1 cycle. Okay, you understand the on the top here going down pi over 2, equivalent 90 degrees, 180 degrees, 270 degrees, 360 degrees, or 0. Okay, so I current right here. Current go into 90 degrees before the voltage, so that's why current lead voltage by 90 degrees. Any question related into the current leading voltage 90 degrees? When you're looking on that thing here on the display, and you know the current leading, and they will be leading 90 degrees. That's the formula. Okay, let's see, capacitor reactant. So example 1, for the circuit in figure number 1, okay, they want to calculate the reactant. We already know IC equal 2 pi FC. Okay, F is 1.5 kilohertz, C 0.05 microfarad. You can substitute it to this formula to calculate it. And then you're going to calculate the current I. Okay, after you get IC, you take the voltage divided to IC, you get the current. Okay, IC just resistance. For the circuit, second circuitry here, they want to calculate the reactant IC, and also they want to know what is the value of C. I think we already did it yesterday. Now, you can see this one. Same thing, capacitor in series. However, they're not using the value of the capacitor. They're using the capacity reactant. So if you want to calculate the total impedance, just add them up. The thing is they're working exactly resistant. Okay? And parallel the same thing. They just the resistance here. Okay? So you can use in the formula. Exactly the same. Add resistance. IC and R in series. Okay, now you see the circuitry 100 volt AC applied to capacitor with IC equal 80 ohm and R equal 60 ohm. Okay, and they're telling you the current I total is the same. That series, only one current. The voltage VR is in phase with VR. We already telling you, okay? That's a 0 here. If you get a VR, and now if you get the current IR, okay? So IR, VR will be in phase. So that's why if you're looking on a oscilloscope, you can see they both go up or they both going down. The value will be different, okay? But they're in phase. So that will be telling you one thing. IT, that means the current through capacitor or through resistor. That's the same. IT or IR in this case. IT, IR will be the same. Okay? And also we'll be telling you IT lead or IC. That I can give IC. That's only one current. So IC lead VC 90 degrees. Okay? IC lead, okay? VC 90 degrees. And that will be telling you same thing. IR, okay, will also lead VC 90 degrees. And also I can telling you VR lead VC 90 degrees. Okay, is it you agree with me? IC, IR, IT will be the same. IC lead VC 90. IR in phase IC. So they also lead VC 90 degrees. And VI and IR will be in phase. So VR will be lead VC 90 degrees. That's a very, very basic. Okay. Now, you see in a rectangular coordinate, if you draw the vector for R, that is for R, okay? And if that is for R, and now we want to draw for HC, okay, if I draw HC this way, they're telling you HC lead R 90 degrees. If I draw HC going down, that means R will be leading HC 90 degrees. Okay? So you have to now understand this is going up in 90 degrees, going down minus 90 degrees. Okay? So now I can draw the vector here, R. First thing I draw R here. Okay? And this is the HC going down. Okay? When I connect that one here, I can get the total will be G total. G total means the total impedance. So if you're learning the math, you know that using the, let's see, formula, G total, Pythagore, equal, okay, square root R square H C square. Okay, that is G total in equals square root R square plus H square. Some question can asking how come they get the 80 ohm and 60 ohm, why you want the total? Why cannot add it 80 to 60? The reason we cannot add it, the thing is they not in phase, okay? So that's why I given you the formula right here. And now if you want to calculate the I total, you take the V total, divide to the G total, okay? You get the total current. If you want to calculate the VR, then you take the I total times R, okay? VC, I total times HC. The last one they want to do in calculation. That means they want to know the phase angle right here. Okay, theta. And from the trigonometry, tan theta equal minus HC, that means HC right here, over R. If you want to calculate the angle, they will be equal tan minus 1 of minus HC over R. Okay. So the question here, what the phase angle theta in here, what is it? What that phase angle telling you? You understand in this circuitry, few things you already know. V total or VR or I total, they will be in phase, no phase difference. VC and IC lead VC 90 degrees. How come we need that angle for this one? What they telling you?
It's telling you the phase difference between the current and the voltage through the circuit. So
Yeah.
in this case, then never mind.
Yeah. Only thing we don't know is the total voltage and the total current. They not 90 degree out of phase. They not in phase. So that's why we need to calculate the theta right here. And then what they say, that will be telling you IT will be least VT by that phase angle degree. Okay, that means the angle difference between I total and the V total. Okay. Okay, now quickly doing calculate for me for that one. Okay. Total impedance. Just apply the formula. If we can get through that thing, they're telling me you really understand what's going on up to this point. I can give you number 1G total.
I got 1.654 kilo ohms for Z total.
Okay, let's see, just a minute. R square, HC square. And what you get?
1.654 kilo ohms.
645, right?
Yeah. Or 5.4, my bad.
54, okay.
chào nhau rồi vĩnh biệt người ngày buồn đã tới ngày giây phút tôi xa người tình đã buồn nhau mình đã thôi nhau.
Okay, who else get the 1.654 kilo?
That's right.
Okay. Number 2, total current. What you get?
1 second. Sorry, I was muted. 1.069 milliamps AC.
Let's see. You get 5 volt. Divide to 1.654.
Oh, I couldn't do that because the 5 volts is volts peak to peak, so I had to convert volts peak to peak to 1.768 voltage RMS, and then did a calculation of that.
Okay, now the thing is when they asking you the total current I, that means they not specify answer will be with I peak or I am at, so it doesn't matter. You just take 5, divide. You take 5 divide to 1.6.
3.022 milliamps.
3.02. I pick, you pick. Milliamp, right?
Right, milliamps. That's peak to peak though, right?
Yeah,
And if you, and like the young lady was saying, if you want RMS or whatever,
you
you
have
got
to
to
get,
transformer and convert, switch it around.
right.
So her answer was probably correct. It's just that she switched it to RMS or something.
Exactly. If
Yeah,
they're not
sorry about
asking,
that.
okay, they're not telling you exactly what they want. I am at or I pick, then just go ahead and calculate like normal. If they given you free pick to pick. Okay, VR. Okay.
Yeah, I got your answer for peak to peak too.
I total time R. So I total, okay, time R will be 1,000.
.022 volts.
VC. I total times C. I see.
I got 3.984 volts peak to peak for VC.
That's correct.
Okay. Angle.
Negative 1,318 divided by 1,000 yields phase angle of negative 9.21 radians. Did y'all get that?
Okay, let's see.
The angle is 52.81.
You get 52.8.
Right.
Okay.
Go see if I can convert that from radians.
Okay, you can take a HC minus HC. Okay. That means 1318 divided to R 1,000.
And Mr. Pham, that negative, that's part of the formula, right?
Right,
Like negative XC over R.
right. Okay, minus 52.8, that's correct. If you don't know how, then I will telling you how to do it. Okay, in your calculator, press minus, okay, 1318 divide R 1,000. Okay, then you can take 10 minus 1 on your calculator.
Make sure they do equal first.
Yeah. So basically, I will be leading. Okay, try to get it clear for every student. It's a very, very basic, okay? Later on, we can get a different way to do. But that normally when you go to the college. However, I still teaching you. But the basic here you must be know. Like voltage, capacitor, current capacitor. Then current will be leading. Voltage 90 degrees. any question on this example?
So then any negative phase angle will be leading, will be I leading, and any positive phase angle will be voltage leading.
Yeah, that will be telling you we already get through. That will be I leading. I leading, I mean I total. Leading V total. V total is not in phase with resistor. Not in phase with the capacitor. However, the current I total will be in phase with VR. The leading VC 90 degree. However, if you compare to the total voltage, then I see I will be leading the voltage 90 degrees. No, it's not, sorry. Minus 52.8 degrees. That's what we're already given to you. Now, try quickly for this example for me. I hope you can get it done quick.
For Z total, I got 216.33 ohms.
Okay, you said you get 200.
16.33 ohms for Z total. I total is
216, right?
yes.
Point what?
0.33.
That's okay.
Let's see, 50 over 2. For current, I got 231.13 milliamps.
VR.
Drop 41.6.
VR mean
41.6.
is it you get a total current, it's right or wrong? 250, 231.
No, the total current is 231.
Then you time R, right?
Wait a minute, hold on.
Oh, it's milliamps, not amps. So you have to divide by 1,000.
Yeah,
It's milliamps.
231
Yeah, that's right. The current is
What?
right.
times 180. You get
Yes.
41.9.
Yeah,
6 or whatever.
41.6.
Oh yeah, I got that too.
No, 41.6.
0.9 is close enough.
Yeah, the thing is, you take 231.1.
Yeah, depending on the number you round it
Yeah,
off or
I'm
something in
180.
the previous step.
Mr. Pham round off too much, so
Okay, 41 volt is good enough.
Exactly. VC.
27.74 volts AC. Once again, 27.74 volts.
You take the current, okay, 231 time 120. 27.
27.7.
The phase will be 10 minus 1 minus HC.
I got negative 33.69 degrees, which means that current is leading.
Okay, good. I lead it. Okay, you get minus 33.69 or close to that number. So now you can see that very simple, easy for you. In order to get at least minimum calculation for RC in series. Okay, now we go next one, parallel. So you get the total voltage is 36 volt, and you get capacitor, they get a capacity reactant 120 ohm, parallel with resistor 180 ohm. And now they try to explain to you, make sure you understand. V total is the same in all component. That means V total equal VC and equal VR. The branch current I through resistor in phase with V total. Okay? The thing is V total the same like VR. Okay? VR IR will be in phase. So that's why branch current I through R in phase V total. And now IC will be lead IR by 90 degrees. How? Easy to recognize. This is the VC. And this is the IC. And the formula is already telling you IC lead VC 90. If they lead VC, then they lead VT 90 degrees. They lead VR 90 degrees. IR, VR in phase. So that's why they say IC lead IR 90. The current I through capacitor lead VT by 90 degrees. IC equal V total divide HC. IR equal V total divide QR. Okay, now you can see we can draw vector for that one. I draw IR first. IR, no phase, 0. Okay, and IC, we said IC lead IR 90. So that's why they go up 90 degrees. Okay, and failure for IC and IR. First thing you draw IR here. second thing IC will be going up to get going up. Then when you connect that thing here, that will be I total. So I total will be calculated by what? Pythagore. Square root IR square plus IC square. Okay? If you want the G total, you take V total, divide I total. And from this display here, you're able to calculate the phase 10 minus 1 of IC divide IR. Okay, quickly get through for me on this parallel RC circuitry.
For IC, I got 300 milliamps.
0.3 amp means 300 milliamp.
Yes.
All right.
Yes.
Just using the formula on the previous page. IR. So 36 divided 180. 0.2 means 200. I total square root in the resistor circuitry only. I total, you can add them up. IR1 plus IR2 plus IR3. However, in the AC circuitry for capacitor, you cannot adding up. The thing is the phase not the same. So that's why you have to use in square root I square plus IC square.
I got 360.56 milliamps.
360, right?
Yeah.
Going what?
0.56.
56
Yes.
milliamp. Perfect. Z total. V total divide I total.
$100 ohms.
Perfect. triangle.
I got 56.309 degrees.
56.3.
I'm not sure about that one.
Ha! We see. Well, normally in the Zoom, if you cannot get through, you can watch the video. Okay, I upload it into YouTube and try redo over and over. Make sure you know what's going on. How come you can get the answer? Is it Mr. Smith? What the angle?
56.3.
56.3, correct. Okay, so this is a second example. I'm not doing it. I already given to you the solution. That's for you to exercise. Okay. Okay. So basically, that will be done with RC circuit. Okay. On this part here, you can get RC circuitry and the next RL. Same thing. RL will be in series in parallel. And you can get the next one, RCL. Okay. L and C only. Series parallel. Then RCL. Series and parallel. Okay. So any question on that one? Okay, if it's not, then I like make sure you try to get to the lab. Okay, try to get the lab, either lab wall or digital lab as much as you can. I'll be there, so any problem, just let me know. We'll help you to fix the problem. Okay, and now, if no more question on that AC circuitry, then Sam will be trying to run the quiz number 2.
That's good. Okay, are we ready?
Make sure they download that report.
Yeah, so make sure you go to the website, make sure you get the, so make sure you go to the handout and come get this answer sheet, the DC quiz 02 report. Okay, so that's what we're gonna be doing today, DC quiz 02. Okay. All right, here we go. Let me see this one here, slideshow, start from beginning. Okay, can everyone see?
Yeah.
Okay, excellent. Okay, so that's pretty much it. So make sure you upload this, the answer sheet to the website before 12 noon tomorrow, okay?
Can I see 14 and 15 real quick? Thank you, thank you.
You're welcome, okay? All right, so that's pretty much it. So anybody have anything that you need to ask before we call it a day today? Now, the other things that we want to now look like the assignment that is going to be coming up because if you go to the website, it's going to ask you to do the assignment called MSIM7 Lab. So this is a virtual simulation that you can simulate your circuit on and be able to collect the data to fill out this Excel to make it pass. Okay. In order to do that, you want to do is you want to come in here, click on the handouts, and then you want to do is scroll down to the very bottom of the website. Okay, and then you right here is MSIM7. Now you have this MSIM7 instruction. You can watch you can look at the instruction. And then after that, you want to download this called MSIM7 student version.zip, okay? So when you do that, now I'm going to do it just one time here, so that if you click on that, so therefore now it's starting to load here. So it's got, once you click on that zip, it will be coming down here. Okay, so now it's trying to download that zip file. Okay, so it's going to take it's not going to take too long. It's only so 81.3 megabytes. So right now it's almost done. Okay, that's pretty much it. And so therefore you want to do is you can click on it to open it up. Okay, now you can see inside your folder, it would be shown here. Okay, and then on the top, it said right here, it said extract. So this one is a compressed file. So you want to do is click. So you want to do is click on that to, and then you look at this one, this folder to the. It's on the top, said extract all. Okay. So this would be stored into your computer. So this one is going to be extracting to my PC, and it's called and it's going to put in my download. Okay. And this called so MSIM 7,1. Okay, so now what I do is click on extract. Okay, click on extract. Now they're going to, and then this screen would pop up. Okay, so this is file will be extracted to this folder. Okay, so and then you want to do is if you want to change a different location, that's fine, but you can keep that same location. I usually normally just keep it and then just click on extract. Okay, show extract file when complete. Okay, so and then click on extract, and now they're going through extracting this into my C drive. Okay, so this take about, now my computer runs pretty fast, so this one is going to take me about a little bit close to 2 minutes. Okay, so that's pretty much it. And so now you can click on this folder here. And so you want to do double click on it to open it up. Okay, now when you open it up, it would show here. Okay, so and then you want to do is scroll down to the folder called setup. Okay, so you want to do is click that one, double click on that to open it up. Okay. So now we have all these folders, and so you want to do is scroll down to the one on the bottom said setup. Okay, so you want to set up the one that says stated for application. Okay, so you want to do double click on that to I think some you can single click, some double click. Okay, let me see. Okay, double click on that to run the setup. All right. Let me see. Okay, so, okay, let me see, open. I think it's probably run in the background somewhere. Okay, so it's still loading. Source resource may affect your article. Try closing some application. Okay, so I got too much application opening up. Okay, so and now you won't see the other the next one that is pops up. It's a user account control. Do you want to allow this app from unknown publisher to make changes to your devices? And then that should be in the yellow. And then after that, underneath that, it's in black. It said setup.exe publisher unknown file origin downloaded from the internet. And you can click on show more details, and then you got the button for yes or no. Okay, so this one you go and say okay, but I know show more details. No, you don't need show more details then. Okay, so you don't. Okay, so when you say that, so when that one said the setup.exe, so click on the word yes for it to start running. Do you want this application to make changes to your computer? Okay, so then you click on yes to let it run. Okay, so when it runs, it should be coming up this sort of something, this page here. Let me see. Okay, so mine looks like it's already completed. Okay. So yeah, sorry, that thing when I click on yes, and then it just completed, it went through, and so you see this page pops up real quick, and then the next page, and then after that, when it's completely downloaded, and then you will pop up this final screen and click on, so click finish to complete setup. So finish. Now some computer require you to restart your computer and some do not. Okay, so in this case, I do not have to sometimes your computer may need some time to get it to reboot to use this application. Now it would pop up this, so you're gonna have the selection, say common component help, and multi-sim 7 or readme. So therefore I want to copy this shortcut. So copy this one here. So you want to right click on it and then just copy. And then you want to do it just somewhere in your desktop and just paste that on your screen somewhere. Okay, so say somewhere here, or now that I have it there, now I can say that I can move it somewhere up here where normally where most of your applications at. Okay, now mine, I put mine here down here in the taskbar so I can be able to do it really quickly, but you can definitely put on your desktop. So now you have to do it, just double click on that. Double click on the MSIM 7 to open it up. Okay, so it would be coming up, and then it would ask if it failed to update the registry. So don't worry about this, just click on OK. Okay, and then it opened up this for you. Okay, so now this is your work station. Okay, this is your workstation, and these are your basic component that's highlighted in blue. Can everyone see that? You can see. Okay, so this is your basic component will be here highlighted in blue. So therefore, if you need a power supply, you want to do is just click on this first one. And then after that, it should be coming some pop up like this here. And then you want to do is put your cursor on the title bar here and double click on it. And then they populate right on the top row for you. Okay. So you need the resistor or something like that. You click on the next component. Okay. Now that pops up. Okay. So now you put your cursor on the title bar, double click on it. And then so they put it right on top of the row for you. Okay, so these are the general purpose components that you can always use. And now if you want a specific component, you use the one to the left, which is in the gray setting right on this side. Can everyone see, or is that too small? Sorry, I don't have the I can't make it any
You can
bigger.
see it. It's high enough resolution.
Okay, thank you. Okay, so these are the you need like a specific source. Okay, when you look at specific one, you want to click on that, and then you want to do is you want to choose what kind. So if I choose this one here, that would represent source. So therefore, I can choose my power source. So I can do my DC power supply, AC power supply, and you got ground, you got different ground. So this is so you got a component ground and you got earth ground. Okay. So you got different, so you got a specific one that you can use. So VEE, VSS. So those are different one that, so like I said, everything on here mainly we're going to be using is the one in blue. Okay. So your general purpose component would be here. Okay. So for example, okay, now that one is, and then your, oops, let me see. And so all your all your instrument would be here on the left, okay, on the right side. So you can put your cursor on top of it, and then they would identify what that component is. So therefore, you can scroll down one at a time, so you can, just experiment with it once you have it open, and so that way you get familiar with all these components. Okay, so now I'm going to say that one for the first one. And now I'm going back into the website. Okay, so for example, I'm going to say that open up first homework. So number 4 here. Okay, so that one's open. Okay, so now, okay, so we're going to be enable editing, close that, and we're going to minimize this one out the way. Okay, so I'm going to put it. So now I have a both screen. Okay, so now I have to do is just choose all these components. Okay, these components. Okay, so power supply is VDC. Okay, so we got DC. So this one look like that symbol right there. So therefore I click on it. Now I can put on my workstation here. Okay, so now my first one. And then resistant, you got resistant 1, resistant 2, resistant 3. So you go resistor, put your cursor on top of it, identify what it is. So that's a resistor. Now I have resistor number 1, resistor number 2, resistor number 3. Okay, so you got 1, 2, 3. Okay, so that's how you do it. Just put your component on here first. Okay, so next thing you want to do is get the ground component somewhere here. Okay. Now you have these, as you can see, this one is aligned it the right way. The long side is facing up. Okay, so now we got R2 here. That one is in the wrong direction. So therefore, you want to click on it. So click on delete. Okay, so that's highlight that, and you can come to edit, and then you can call now edit. You can do flip horizontal, flip vertical, 90-degree clockwise or 90-degree counterclockwise, or if you remember the shortcut key on your keyboard, you can use it. So that's Control R to do that. So therefore, now you can also right click on it, and then you have the option to turn it. Okay, so I'm going to say clockwise. Okay, now it turned exactly in this direction, or in vertical direction. Okay, so let me go ahead and sort of enlarge that a bit. Okay, is that a little bit clearer to see? Okay, so that's how you do it. So just put your component on here, and then now we can identify. So this is 1K, this is 1K. So this one is 1.5K. So this one right here. So that value, we need to change it. So we have to do is just double click on that. and that would bring this one, so this is the label that we can change. We can change the label, we can change the display, we can change the value. In this case, we need to change the value. It's 1.5K, so 1.5, okay, and then it should be kilo ohms. So this one here, your unit, that is correct. So we got kilo ohms, click OK, and now they change. Now once you click OK, now they change it here on the resistor, okay? Now resistor number 3, same thing, we come here, double click on it, and we change it to 150. And this one say kilo ohm, so therefore I need to change that into ohm. Okay, so ohm. Click OK. Now that is this. Now it changes to that. Okay, now in order to connect them all together, you want to do is put your cursor on top of the lead. Okay, so now you click on it once. Okay, and then you sort of drag it and then drag it to the lead of the next component, and click on it one time. Left click, and it would connect that circuit. That wiring will be connected. Okay, so now we can do the same thing to the next one, and then the next one. So when we come to the beginning of the lead, click on once, go to the lead of the other, click it to connect it. Now you go to the common, click on that once, and then go to right here, click it, now connect it. And that's what you have, one single dot right here. So therefore, one single dot, okay? So the next thing you want to do is label A, B, or C. Now you can go same thing with edit, and you can say, okay, so edit or place, okay, place, you can place text, okay? So Control T to place text. So you want to do it, just come in here. So therefore, you type in the word A for, let me see, that one would be A. Okay, so A, and then you want to do double click it a couple of times to exit out. And then now you can do the next one. So place, text, and then we can choose a location, put B, capital B, and then double click it a couple of times on your workstation to exit the text mode. Now, next thing you want to put next text. So go to place, scroll down to the word text, or Control T, and now you can put the next label. So that's a C. Okay, so now we double click on the workstation 2 times, and that would exit that. And then you can drag this one to any location that you wanted to. Okay, so now we do is pretty much, that's pretty much it. Now we have to do is just follow whatever they, you know, what you have to do. So they want to measure VB, so therefore you want to do it, go in here and looking for your multimeter. Okay, so this is multimeter. Now you can use this one. Normally this is the one that we use. Okay, so you want to do is, it's these. So you got 1, 2, the third one from the bottom. Okay, so that so you want to click on and then drag it and then just put it over here. Okay, and then after that you want to do double click on it. Okay, to bring it out the meter. Okay, now just have to do it, just put somewhere down here so you can see. Okay, now you can turn the power on, which is the power on button is right here. Okay, now this one we want to measure is going to be VDC, not VAC. So therefore we want to change the source to DC. So right here say DC voltage. Okay, so DC volt. So click on this button. Now it changes from VAC to VDC. Okay, so now you want to do is you have this component right here. It's an input. You got volt, you got ohms, and you got diodes. Okay, so that's what we're going to be using. We need to measure voltage. And so the common would be this one here, the ground level. Okay, ground will be somewhere in the middle. So this one would be the ground. Okay, so VB, so the common would be, since they only get one location, therefore the other one had to be connected to the ground. And the high side, the voltage side, would be at point B. Okay. Now that's connected, you want to do is turn on your simulation. Now you can move your switch around, you can move your switch around, you can put it here, or you can put it here, doesn't matter. You can put it like at the beginning. And so therefore, depending on how you want it, it's easier for you to locate, okay? So you have to do is just turn on your simulation or press F5 on your keyboard. So therefore, I turn on my simulation, and that's what it give me the value. So this one, the source is 12 volt. I want to make sure that I have 12 volt. Okay, 12 volt, 12 volt. Okay, so therefore that's correct. So now they want this one is 7.47 VDC. So your voltage VB right here, it'd be 7.47. Okay, 2 decimal places good enough. Okay, you don't need to go more than 2 decimal places. So, all right. So that's what you do, and then after that, convert this one to millivolts. So therefore, you want to do is just take that equal, and then take this one and multiply by 1,000. Okay, and that's converted to millivolt. Okay, so that's 7470 millivolt. All right. So next one is VC. Okay, so now you want to do, in order to disconnect this, you want to have to turn right now. If you could click on it, see this one is shaded in gray. So therefore, I can't delete it. So I choose this wire, and then I push delete on my keyboard, and I cannot delete that. So I have to turn this one off first, because you have to turn off your simulation before you disconnect it. Okay, now that disconnected, next thing I want to do is connect to point C. So there, and then scroll down and then put C. Okay, and then you turn on your simulation, click your next data. Okay, so 679.245 millivolts. So therefore, this one's a millivolt. So therefore, I look at the lines at millivolt. I come down here. I put 679.24. Okay. And that's in millivolts. So that's why I had to put in the line at the millivolt. Now I have to convert it to volt. So therefore, I take that number divided by 1,000. Okay. So if you go up, you have to, when you go up, you divide, you go down, you multiply. Okay, so that means same thing as 0.769 volt. Okay, so now that's pretty much it. So pretty much you just do that. If you do the lab, if you're working in the lab, this one would be a piece of cake for you. Okay, next thing you want to do is find the current to R1. So R1 is right here. So therefore, you can disconnect this one here, or you can disconnect the one after. It doesn't matter which one it is. So I want to do is the one after, for example. All right. So now we want to look at current. So current is this one right here. Say I. So therefore, it has to be the bottom one. So the I one be right here, the high side, and that should be connected to the high side. So on this side, the starting side, and the common would be connected to the other side, to the point B. Okay, so wherever the disconnected, that's where you put one at the starting, one at the end. So therefore, this one will go through here. The current will be flowing through here, through the resistor, go through here, go through go to the port, the current port, and then after that it goes to the common, and then it travel back through the common, and then continue on throughout your circuit. Okay, so you want to force all that current through your meter, and then from your meter continue on the rest of the circuit. So now you want to set that one up. Now you want to do it. We need DCI, so therefore it's in the shaded here. It's on the second. It's in the second option. So therefore you have to push the shift. Okay, so push the shift button, and then you put the DCV here button to use the one in the upper the top mode. Okay, so now you choose this one. Now change to amp in DC. So now we got in current. Now we turn on your simulation and click on data. Okay. Oh no, that's VDC. Sorry, that was measuring the current. So down here, so current doesn't matter where you can look at that the source, or you can put. So in series, there's only one current. So this one is 4.52 milliamp. So milliamps right here is 4.52. Okay, and then you do your conversion. I'm not going to do that. You're going to do that later. Okay. So now I'm going to delete this one, turn off your simulation, and now I have to connect this one back. Okay. So VR1 is right here, and it's between A and B. So therefore, you're going to, so you want to put back into DC voltage. You want to put the voltage side at point A and then the other one at point B. Okay, so just across this, so your meter would be running parallel with the component. Okay, so therefore now you turn on your simulation and collect your data. Okay, so it's 4.553. Okay, so 4.53. All right. So you can, and that's voltage, and now you continue on with the next one. Turn off your simulation and click on the line, the wire connection. Push delete on your keyboard, and then choose the next one. Delete. Okay, VR2, it's between point B and point C. So point B going to be here, and then point C is going to be on the other side. Okay. So now we turn on the simulation, collect your data, and so that's 6.79. Okay. Okay, and so on and so on. And then the next one. And okay, so delete that. So delete that. And the next one, VR3. So 3 here between C and ground. So therefore, the high side had to be at C. And this one should be at ground side. Okay, turn on your simulation. 679.245 millivolt. So millivolt here. So I come down here, 679.24. Okay, and then you can do your conversion. You can do that conversion. Okay, so now once you have all that data information, next thing you want to do is right here, say to calculate power. Okay, so power, you can use the, so you got R times I square or V times I, or R3, okay, R3 times I. So we got VR3, so VR3 right here, and we want to do is in, so we got this one here, milliwatt, and so we want to do is, since this one is in, so we're going to use this, so this one divided by the, so you want to use this one, look like okay, so they want, you want to use resistant, or the R3 and the current. Okay, so we got current here, and so you got the, okay, so you got this one square, and you want to divide it by, okay. So we're gonna look at the same thing, convert this one to to voltage. So take this one, divided by 1000. Okay, so this one, same thing. Start with the equal this cell times 1000. Okay, so this one is equal to this cell times 1000. Okay, so now we have the current. So we got voltage and we got current. Okay, so now we can use that voltage times current law. Okay, so same thing, V times I. So therefore this one is equal to, okay, so we got R3. So we need the voltage at VR3 times the current. In this case, we want to end up milliwatt, so we need the milliamps value. Okay. Okay, so that comes about 3.07. All right. So ohms, now resistant. So you can do, you can go ahead and add it, this one all together, or you can measure it with your meter. Okay, so therefore, in order to measure with your meter, you have to disconnect it from the, so isolate it from power supply. So therefore you delete that. So then now this one is not connected. Now we want to change this here, the mode to ohm. So this third button on top row. Okay, so now change to ohms. Okay, now the ohms is this one here, say it high ohm. So therefore I need the high side, put it one side on this side and the common side. So connect it to the common. And you turn on your simulation and click your resistance. So 2.65 kilo ohm. So they want an ohm. So therefore we do is take that. So 2.65 times 1000, that would be changed to ohm. Okay, so 2650 is your value of ohm. Okay, so as you can see, now we got something that is incorrect. Okay, so I need to convert this one to micro. So therefore this one is equal to this one times 1000 to convert it to micro ohm. Okay, so look like everything's done. Okay, so as you can see, so that's the value. Okay, so now that it passed. Okay, so and then you just make sure you put your name on your sheet before you save it. Okay. Just say save as for me, browsing. So this one is in my PC, this PC in my D drive, and I'm going to put in my summer. This one is Tech 1 assignment, and this one is my Excel. So, and this one is assignment 4. So therefore now I just have to do, for me, I just like to just kind of, so this is assignment 4, SP, no, this is summer, SUM. This is 2022. Okay, so now I know assignment 4, that is done. Okay, so that's the one that passed. I can save it, and then later on I can upload it to the website. So any question? Sorry about that. I went through pretty fast. So, and then you can watch, like I said, this way it is safe on the video. Mr. Pham can upload it to the website, and then you can follow through on that. See if you guys can download the, just follow the instruction and upload it and do the first simulation of the first assignment, and to see if it make it, if it works for you. And if you have some problem, we can answer tomorrow in the lab. Okay.
I was having some issues accessing the dynamic measurement probes. Have those been disabled for reasons?
Okay, let me go ahead and stop this one. Okay. Go ahead and can you share your screen with us?
Oh, sure.
Okay.
Where are you? I'm just used to, if you go to simulate instruments, this one's disabled.
Okay. You want to do, you want the agent multimeter, so the one on the third one from the bottom, the third one from the bottom, right there. Click on that
Oh,
one.
we're using those. Okay.
Yeah, that's the one that was mentioned. Yeah, everything is on your right. Like I said, everything is, all your instrument is on the right side, or you can scroll down and choose that. Okay.
Thanks.
Okay, yeah, follow that. You know, like I said, just follow what I just went over the simulation. And Mr. Pham, just follow that example, see if you can do it. And then if you still have some question, I can be able to answer in the lab tomorrow. Okay. Okay, so that's pretty much it in a quick session. All right. I'm sorry that we have to go through it pretty quickly, but like I said, so I have some more time to answer in the lab tomorrow. Okay. All right. That's pretty much it. Thank you, Mr. Pham.
Thank you, Sam. That's
You're welcome.
very good.
Yeah, thank you.
If they not follow it, they can watch the video.
Yes.
Okay.
Yes.
So good night,
Good
everyone.
night. Okay.
Good night.
Good night.
Thank you. Have a good night.
Good night.